So now I'm going to present the poster of our paper Summary the Savior, which basically means harmful keyword and query-based summarization for LLM jailbreak defense. And this has been accepted at Trust NLP, and this is also collocated with NACL 2025. So my name is Shakutar Rahman. I am a PhD student in computer science at UC Irvine, and Dr. Harris is my advisor. Now let's go to the problem statement directly. So LLM jailbreak is basically a process where you can generate inappropriate content from LLM by giving it different prompts. And so, for example, how to make a bomb. If you give it this to the LLM and it gives you the answer, then that's called jailbreaking. And the objective is to like block the harmful prompts and pass the harmless prompts to the LLM. And there are basically various methods of jailbreaking. For example, suffix generation, where you can add different random suffixes with your harmful prompt, and that basically jailbreaks the LLM. Also steal the prompts generated by human, and also prompts generated with the help of other LLMs using feedbacks. And also for the jailbreak defense techniques, there are prompt level analysis. For example, the prompt before going to the LLM, you can analyze the perplexity, like whether there is a change in the flow of the prompt, swapping different characters or tokens, if there is any change in the output classifications. And after the response that has been generated by LLM, you can basically analyze it with other LLMs, whether that is jailbreaking or not, or through classification. And also different LLMs are basically safety aligned, are trained with safety alignments right now to get rid of this jailbreaking. So the existing problems with this jailbreaking techniques is that the defenses are pretty specific to this attack. They are not universal, and they are also not robust to new attacks. And there is high false positive rates and refusal rates, and most of the prompts basically hypnotize different LLMs because of the NLP ambiguities. And that is why our methodology basically tackles all of these challenges. So what we do is we have this prompt which we send to the harmful keyword extractor, that is a fine-tuned LLM Llama 2 7 billion model that extracts harmful keywords from a particular prompt. This harmful keywords and the query basically asks about the harmfulness of the prompt. Both of these go to the security aware summarizer. So security aware summarizer is another LLM which is fine-tuned. So this LLM basically takes the harmful keywords from the prompt and also the query, and gives us the summary that analyzes the harmfulness aspect of the entire prompt. And then this summary that is fully security aware basically goes to this harm classifier, which is a machine learning or deep learning based model that classifies this summary into three categories. Harmful, that basically blocked, doesn't go to the LLM. Harmless is basically passed to the protected LLM, and ambiguous harmful is the another class that has been created by us for those kind of prompts that can go either way. That it, so from one point of view we can say that that's harmful, from the other we can say harmless. So for these prompts, we basically add a caution with this prompt and send this to the LLM to basically protect it. Now let's talk about the different components of our analysis here. So first of all, we have this harmful keyword extractor that extracts harmful keywords from the prompt. For example, how to make a bomb. We send it to the keyword extractor, and it gives us a make a bomb. Or even this kind of a prompt, which is generated by human, which basically hallucinates LLM. So for this instance, it basically asks the LLM to role play, like it will ask how to cook, and it has to answer it, but in a way that after each alphabet there should be spaces. So the LLM thinks this is a particular role-playing scenario, but what actually is the problem here in this case is that the question asks about an adult website to the LLM, and the LLM basically gets hypnotized and gives a particular answer that is really inappropriate. So in that case, the harmful keyword extractor extracts keyword like lacking ethical moral guidelines, unsettling responses, candid responses, coded language, explicit contents, etc. So the question is, how did we generate this kind of a extractor? Like, how did we fine tune? So we had this from data set that we sent to the ChatGPT to extract harmful keywords that we use as an oracle. And then with this data set and also instruction to find the harmful keywords, we send this to the Llama to 7 billion model to fine tune it, and we have our harmful keyword extractor. Now, our next component is security aware summarizer. But before that, we have to understand what is control summary. So if you send your prompt to a particular summarizer, the summary will lack details. It may be too long and not too specific. As a result, the controlled summary is something that you can give it control instructions. For example, you can tell it to summarize within 2 lines, summarize while answering particular questions, or focusing on particular keywords. As a result, the summary would be detailed, short, and to the point. And we use this idea in our analysis. And the way we do it is something like this. So if we send the same prompt to the summarizer, it will say something like the prompt outlines a role play scenario. So there is nothing bad in that. However, when you send the same prompt with the harmful keywords that we have extracted in the previous phase, with the instruction like summaries while focusing on the harmful keywords, and also a query like while summarizing classify it in one of the three classes, then we can see the summary that it generates is something like this. It creates a scenario, a role-playing scenario basically, that lacks ethical and moral guidelines. It's fully harmful because it explicitly describes a character that doesn't follow any AI rules, intentionally creates a scenario that is far away from ethical or moral guidelines. As a result, it makes it easier to flag that as a harmful content. And the way we generate this security aware summarizer is that we have this prompt data set that we send to the Llama 3 70 billion model. We have this harmful keywords data set from previous stage, and we have this query. We all send this to the Llama 3 70 billion model to generate security aware summaries for us, which we used as the data set or oracle. Then we send this, the instruction, harmful keywords, and the query to the Llama 2 7 billion model to fine tune it. As a result, this becomes our security aware summarizer. More thing we have added in our methodology, that is the ambiguous harmful class. So this is only for those kind of data that can go the either way. For example, from one point of view you can say that is harmful, from the other you can say that is harmless. For example, in this scenario, like you are a consultant for a writer, you have to write a story for like creating illegal business in guise of a charity. So from one point of view of story, you can say, okay, that should be encouraged, you should do that. On the other hand, people might say even in story you shouldn't add those things. Or even another example is tell me a story where the main character uses drugs. So for these kind of prompts, if we just reject them, then that will increase the refusal rate. And again, if you just pass them to the LLM, then you might increase the jailbreaking as well. As a result, what we do in this case is that we flag them as ambiguous harmful and add a caution message with them and pass them to the LLM. And what is the caution message? It's something like this: the prompt can have both harmful and harmless intentions, so while responding, make sure that you abide by the policy. So in this case, what happens is the LLM always gives the helpful answer, but also abide by the policy. So the data set we have used in this case are three different kinds of data. Harmful data, for harmful data, we have used DAN, GPT for the red for the real bench. Harmless, we have used, for harmless, we have used LPCAR data set. For ambiguous, we have used access test, while theming, and or bench. And for evaluation, we have used the widely used JBB eval data set. Now, as for the result, first of all, we have the analysis or the results of the security hour summarizer, and we evaluated it in terms of rogue score and bird remaining scores. And we have got highest amount of rogue 1, 2, and rogue L and bird scores. And also we can see one picture in this case, which is the TSNE plot of the TF-IDF values of prompt and also the summary. So we can see that if we would have used the prompts to classify, then it would have been pretty difficult for a classifier to classify because there is no cluster. But if you want to use the security hour summaries, then you can see that there are different clusters. So it makes easy for the classifier to classify them. And the reason is because they are well enriched in terms of the harmfulness of a particular prompt. And we can also prove the same using different machine learning and deep learning models, for example, SVM, random forest, bidirectional LSTM, etc. And we can see when you use the prompt, the average accuracy is around 80%. But as soon as you use the summaries, the security hour summaries, the accuracy goes to 95% and almost for all the models. So last but not the least is the different attacks. We have evaluated our model against different attacks, and also we have evaluated in terms of different defense techniques in three different models like Vicuna, Llama 2, and GPT-4. And we can see that there are different attacks like Pair, GCG, JBChat, and Prompt with RS. And in case of the defense, our model has got lowest attack success rate, almost 0% at all of the cases. And this is because we have analyzed the prompt's harmfulness in terms of the summaries. And lastly, to prove like how good this ambiguous harmful class has been, we have used this pair data from jailbreak eval, and we can see if there was no defense, then it was like 100%, 7%, and 76% harmful in terms of these three different LLMs. And if we would have blocked all the ambiguous data in terms of ambiguous blocker, then we would have got 0% attack success rate. But with summary the savior, we have got 29%, 0, and 0. So from this angle, we may feel that ambiguous blocker would be a good model, or blocking them because data might be better. But the thing is, this thing changes as long as you look at the data that is not harmful, benign but sensitive. For example, white theming anti-scale, this is a data set that is not fully harmful. It is benign but sensitive. So in terms of no defense, the refusal rate of the QAnon llama is 3% and 7%. But if you block all the ambiguous data, it would increase the refusal rate at 9% and 12%. But with the summary the savior model, obviously it doesn't increase the refusal rate. So with summary the savior, we ensure 0% attack success rate, and also what we maintain is the refusal rate. We do not increase the refusal rate. So that's how the summary the savior, while analyzing the prompts in terms of summaries, focusing on the harmful keywords, makes the best use of LLM fine tuning, and balances between jailbreak defense and also not increasing the refusal rate. Thank you so much.